So students, now let's start activity 2.1 relations. Objective for this activity is to verify that for two sets A and B, and A into B is equal to M into N, and the total number of relations from A to B is 2 to the power M into N, where number of elements of A is equal to M and number of elements of B is equal to N. So students, now let's see the method of construction for the given activity. Step 1. Take a drawing cardboard and fix a white sheet of paper on it. Step 2. Draw a set A1 with one element and set B2 and set B1 also with one element. So A1 is equal to A1, that is only one element, and B1, set B1 is equal to containing only one element. So the both set A1 and B1 has one element. Now step 3. Draw another set A2 and set B2 containing two elements. That is A2 equals to, set A2 equals to A1 and A2, two elements, and set B2 contains two elements B1 and B2. Step 4. Draw another set A3 and set B3 containing three elements each. That is A3, set A3 is equal to A1, A2, A3, three elements, and set B3 has three elements B1, B2, B3. Three elements A3 and B3. So students, now let's start the demonstration for the given activity. Step 1. Let us represent sets A1 and B1 containing one element each, representing all the possible correspondence of the elements of set A to the elements of set B. Let's represent it visually in the form of a Venn diagram. So this is set A1 containing only one element, that is A1, and this is set B1 containing one element, B1. So now the is represented in this manner. So hence we have represented the relation of the elements of set A1 to the elements of set B1 in the given Venn diagram. So now step 2. Represent the sets A2 and B2 where the elements of A2, set A2 is equal to A1, A2. That is, set A2 has two elements and B2, set B2 also has two elements, B1 and B2. Now represent all the possible correspondence of the elements So now represent all the possible correspondence of the elements of set A, that is A1, A2 to the elements of set B, that is B1, B2. So now representing it visually, first let's draw a rectangle and represent the set A1, A2 representing the set A2. Similarly, B2 representing elements B1, B2. So now the possible correspondence of the elements of set A2 to the elements of set B2 is A1 to B1 and A1 to element of set B2, B2. Similarly, A2 to B2 and A2 with B1. So this is the possible correspondence of the elements of set A2 to the set B2. So students, now let's represent step 3 of our demonstration So now let's represent set A3 equals to A1, A2, A3 and B2 as B1 and B2. So now let's establish the correspondence or the relation between the elements of set A3 and B2. So now we present all the possible correspondence of the elements of set A3 to the elements of set B2. So now let's represent it visually. First let's draw a rectangle. Now let's represent set A3 A1 A2 A3. So the elements of set A3 are A1, A2 and A3, and the elements of set B2 are B1 and B2. So the possible relations that can be formed or the possible correspondences is A1 B1 A1 B2. Similarly, A2 B1 and A2 B2. Now A3 B1 and A3 B2. So this is the possible relation or correspondences between the elements of set A3 and set B2 that can be represented visually using this Venn diagram. Now step 4. Represent the set A3 equals to A1, A2, A3 and set B3 equals to B1, B2, B3. So the elements of set A3 is A1, A2, A3 and set B3 is B1, B2, B3. Now show all the correspondences of the elements of set A3 to the elements of set B3. So let's represent it visually using a Venn diagram. So now let's represent first set A3. So the elements of set A3 are A1, A2, A3, similarly, set B3 and the elements of set B3 are B1, B2, B3. Now let's establish the relation between the elements of set A3 and B3. So A1 is to B1, A1 is to B2 and A1 to B3. Now A2 B1, A2 B2 and A2 B3. Now A3 to B1, A3 is to B2 and A3 is to B3. So this is how we visually represent the relation or the correspondence between the elements of set A3 to the elements of set B3 visually. So students, in the similar way we can show the visual representation representation between the elements of any set A and set B. So students, now let's see our observation for the given activity. So we have constructed an observation table, and first column mentions the Cartesian product of sets. That is, our first Cartesian product was A1 into B1. The number of elements in Cartesian product. So the number of elements in A1 was 1 and in B1 also 1. So the total number of relations become 2 to the power number of elements in set A1 to the number of elements in set B1, that is 1 into 1 equals to 2 to the power 1 equals to 2. Now similarly, our second Cartesian product of sets was A2 into B2, that is set. Set A2 was 2 and number of elements in set B2 also 2. So the number of elements in Cartesian product becomes 2 into 2, 2 to the power number of elements in Cartesian product, that is 2 into 2, which is equal to 2 to the power 4 equals to 16. Our next Cartesian product of sets is A3 into set B2. So the elements in set A3 was 3 and B2 2. So our total number of relations become 2 to the power Cartesian product of elements in both the sets 3 into 2. So 2 to the power 6 equals to 64. So there are 64 relations in A3 into B2. Similarly, the set A3 into to the set B3. Now the elements in both the sets are 3 each. So our Cartesian product of the elements becomes 3 into 3. So the total number of relations become 2 to the power 3 into 3, which is equal to 2 to the power 9 equals to 512. So there are 512 relations in the set A3 to the set B3. Hence, our conclusion, or we conclude from the given activity and our observations that for any two non-empty set non-empty finite sets say A and B containing the elements M and N respectively, then the total number of relations from A to B, that is set A to set B, is given by two to the power m into n, that is the elements in set A into the elements of set B. So this gives us the total relations from A to B.